You are here. Here is where we live. This is where we call home. But how did this happen? 4.6 billion or so years ago, what we know as the Earth was formed. Earth was basically the universe's DIY project. I'm gonna whip up something that no one's gonna understand, said the universe. Was this magic? Or was it God? Now, when it comes to how the Earth was formed, some suspect it was like the universe's version of a hot date with a big bang. Others wonder if it was a result of cosmic mixtape gone wrong, with stars and galaxies swiping right on each other. When you look around, you'll see all black. Outer space is not completely empty. It is a near perfect vacuum containing a low density of particles, predominantly a plasma of hydrogen and helium, as well as electromagnetic radiation, magnetic fields, dust, and cosmic rays. So technically, that is what space is. But what is it? Why does it seem endless? To answer these questions, we have to look back to Einstein's theory of relativity. I promise you, bro cooked here. Just hear me out. According to general relativity, the space-time is a four-dimensional object that has to obey an equation called the Einstein's equation, which explains how the matter curves the space-time. I know it sounds a little confusing, but hear me out here. Now imagine you and your homie was driving in the car. You see your homie next to you. And as you're moving at the same speed, that would mean you and the brother was stationary, since you and bro are moving at the same speed relative to the movement of the car. This is called being stationary, relative to outside, straight cruising. This is what we call relative motion. Einstein's theory of relativity helps us understand space. But at some point, my homie Einstein said, what about light? Light is in space, so light is space? No, said Einstein. Photons move super fast, So maybe time hits different. You feel? Said Einstein. This is when someone said, yo, why is he yapping at us? Then Einstein said, wait. Hold up, let me cook. And when I say bro ate, he ate it up. Now imagine a bouncing ball. Always in motion, or constantly bouncing up and down at a constant rate of motion. If you're just chilling, but your homie is in space, cruising, also bouncing a ball at the same exact relative time as you. Since homie is moving at a constant speed relative to you, that would make you stationary, and him at a constant rate of motion. Got that? But that's where the issue comes in with space. Light in space is always in constant motion relative to you. So since the light is always on the move and you are not, or at least the same speed as it will never change, like my drip. Straight fire. Let's call this a cosmic speed limit. In space is the 12. So let's get back to our scenario where you're chilling with a ball, but bro is cruising through space relative to you, with the ball in the same motion. Now, we are each bouncing the ball at the same exact speed, same rate of bounces per second, no change each time. Now, but since you are not moving and bro is, both of the balls will stay at the same exact rate. But since bro is in a constant motion and you are not, in our perspective, the ball is at the same rate of speed. What the heck? How is this even possible? Light can't move faster than the cosmic speed limit. So something has to take the fall since it's the rule of space. So what happens is time will slow down to make up the difference of you and your bro. So as you move faster and faster, time will literally slow down to match that motion. We'll call this a time delay. But there's more stuff that happens. Since time can contort and bend depending on speed, time is like space that needed its own place to do its own thing. But your boy Einstein was like, nah. These are the same thing. Time and space exist concurrently, not apart. So then, what is it? Time, space, or space-time? Yes. You see, time cannot be separated from the three dimensions of space. Your boy Einstein kept yapping and said, let's put them together. Space and time formed a fourth dimension called space-time. Who didn't see that one coming? So space is time as much as time is space. Makes sense, right? Just imagine space, like you're laying on the bed, and space is the blanket. Your body will fold the blanket and it bends around you. Like anything that jumps on the bed with you forms in with the bed, and the blanket creating a dent or a bend, as we'll call it. So the faster you come closer to the dent in the bed, the faster you start moving. It's like falling down the slide, but if you're in the middle of space. Or outside the bed, nothing will bend with you, and you're just chilling. This is called being stationary. This would also be called time dilation. The further you move away from something, the slower time will move. So yes, time is space, and space is time. Outer space is the vast, dark, and airless expanse beyond Earth's atmosphere, where unique conditions and celestial objects are where time and space are one. Once Einstein spat those bars, and everyone agreed he was in fact not yapping, the theory of relativity was born and universally used to define space. Straight-goated, and he is simply just him.